Uh, with a very good afternoon, my dear students. I welcome all of you for the class. And yesterday we have studied the various concepts. We have revised those concepts, and now let's move and study about the various uses of the aldehydes and ketones. So we are going to study the various uses of our aldehydes and ketones in details. Let's move forward. The various uses of aldehydes and ketones, if we study, my dear students, in chemical industries, aldehydes and ketones are used as a solvents or starting material for the preparation of various other compounds or as a reagent for synthesis of the various products. So this is how, my dear students, we study about the first use of our aldehyde and ketone. We have seen that these aldehydes and ketones can be used as a starting material for the production of the various compounds. At the same time, they are used for the as a solvent for various reactions, and they are also used for the they are used as a reagent even for the various other reactions, my dear students. So uh, this is how we understand about the first use. The second use, formaldehyde is well known as a formalin. So, 4% solution of formaldehyde is known as the formalin. Remember, my dear students, it's a 4%, not 40%. Remember it well. 4% solution of formaldehyde is used as a preservative, and it is used for the preservation of the various biological specimens into the biology lab. Next, my dear students, uh, this formalin is used as a preservative, as a biological specimens to preserve the various biological specimen, my dear students. Uh, Now, my dear students, we will move to the next one. This formaldehyde is also used for the preparation of the bakelite, which is a phenol formaldehyde resin. It is also used for the preparation of urea formaldehyde glue, which is again a kind of resin. And this formaldehyde is also used for the preparation of the various polymers. The next use, my dear students, that is about the acetaldehyde. Acetaldehyde is used primarily as a starting material in the manufacture of acetic acid, ethyl acetate, vinyl acetate, and various polymers and drugs. Once again, this acetone is used for the preparation of acetic acid, ethyl acetate, vinyl acetate, and various polymers and various drugs, my dear students. Now, let's move forward and understand the other uses. We have benzaldehyde. This benzaldehyde is used in um, perfumery to prepare or to make the various perfumes, and in the dye industries. So benzaldehyde is used for preparation of perfume and dyes. Dyes means those which give color to the other substance. They are known as dyes. Acetone and ethyl methyl ketone are common industrial solvents. So acetone and ethyl methyl ketone, they are a very good solvents. If you really write ethyl methyl ketone, it is actually 2-butanone, my dear students. This is your ethyl methyl ketone, which is 2-butanone. So acetone and ethyl methyl ketone, or propanone and 2-butanone, are the very good solvents for the various industrial purposes. Many aldehydes and ketones, example butyraldehyde, vanillin, acetophenone, camphor, etc., are well known for their industrial, for their flavors and their odors. So many aldehydes and ketones are used to give the various flavors to the food or various smells or odors to the food and drinks, my dear students. So this is how we understand about the various uses of our aldehydes and ketones, my dear students. Now, my dear students, we want to study about a very important part of this chapter, which is known as the carboxylic acids. So let us start our study about the carboxylic acid. Carbon compound containing a carboxyl functional group, that is COOH, are called the carboxylic acid. Those carbon compounds, my dear students, can you see what I am sharing? Dear students, can you
Yes,
see
sir.
what
Yes,
I
sir.
am?
Yes,
Yes,
sir.
sir.
पहले नहीं दिख रहा था,
Yes,
अभी
sir.
दिख रहा है, ऐसा हुआ?
Yes, sir.
Was it not visible when I was reading the uses?
Yes, sir.
बेटा मैं जब uses पढ़ रहा था तब आपको नहीं दिखा रहा था?
No, sir.
Yes, sir.
नहीं दिख रहा था ना?
Yes,
Okay,
sir.
let me revise it once again for you. My dear students, we want to study the various uses of the aldehydes and ketones. Let me give you a brief and a fast revision so that you know there will be aldehydes and ketones are very good solvents. So they are used as a solvents, my dear students, or they are used as a starting material. They are used as a reagents to prepare the various industrial products. Formaldehyde, which is 4% solution of formaldehyde in water, which is used in biology lab for preservation of the various biological specimens. Uh, the formaldehyde is also used for the preparation of bakelite, which is a phenol formaldehyde. Formaldehyde is also used for the preparation of urea formaldehyde glue. Formaldehyde is also used for preparation of many other polymers, my dear students, and many other products. Then, my dear students, we have acetaldehyde. Acetaldehyde is primarily used as a starting material in the manufacture of acetic acid, ethyl acetate, vinyl acetate, and many other polymers and drugs. Benzaldehyde is used in the perfumery industry, that means for making perfumes, and for it is used in the dye industries. Dye means something that gives colors to the other substances. Acetone and ethyl methyl ketone, that means propanone and butanone, my dear students, they are used as a very good solvents. And many aldehydes and ketones, for example butyraldehyde, vanillin, acetophenone, and camphor, are used to give odors and flavors to the various foods and drinks. That means the various flavors to the foods like ice cream and various flavors to the various cold drinks is because of such aldehydes and ketones that are used for providing the odors and flavors. Now, my dear students, we are going to study about the new part of this chapter, which is known as the carboxylic acid. Carbon compound containing a carboxyl functional group are known as the carboxylic acid, my dear students. The carbonyl group consists of the carbonyl group or carboxylic consists of carbonyl group attached to hydroxyl group. Hence, it's named as the carboxyl. You know, carbonyl plus hydroxyl. That is what it
Sorry.
is, carboxyl. I hope you understand now. Why do we call it carboxylic acid? We call it carboxyl or carboxylic acid because carbonyl plus hydroxyl. First part from carbo, hydroxyl last part, and finally it becomes as a carboxyl group. So that is why it is known as carbonyl plus hydroxyl. That is what it is finally turns out to be, carboxyl group or carboxylic acid group. Carboxylic acid may be aliphatic. Aliphatic means carbon have got the chain, not ring, but chain. They may have some branches here or there, but this type of chain of carbon is known as aliphatic. If they are not ring compound, they are not cyclic, then they are called aliphatic. So carboxylic acid may be aliphatic carboxylic acid or aromatic carboxylic acid where you have the at least benzene ring, or they may be cyclic carboxylic acid like cyclohexanoic acid, or there is a COOH group bonded to the this cyclic hydrocarbon. So this is how we can have the aliphatic and aromatic carboxylic acid depending upon the group alkyl or aryl attached to the carboxyl carbon. Large number of carboxylic acid are found in nature. So what are those carboxylic acid found in nature? Let us study. First we should study or we should know about the definition of fatty acids. Some higher members of aliphatic carboxylic acid. Higher members means they have the more number of carbon, that the carbon number ranging from carbon 12 to carbon 18 are known as fatty acids. So fatty acids are the carboxylic acid which have the carbon numbers ranging from C12 to C18, or those fatty acids which have
सर
number of carbon. Hello, yes.
देखा तो नहीं, देखा तो नहीं सर.
नहीं देखा तुम
ना सर.
यार
Yes, sir.
જ્યારથી દેખાવાનું બંધ થાય તરત કહી દો મને. કોઈ છે જે આ મારી શેરિંગ બંધ કરી નાખે છે. I don't know who is doing this, but there is someone from the students who is knowingly or unknowingly stop my sharing. As soon as you stop watching, मतलब as soon as you cannot see, you immediately stop me and tell me so that I can do it for you. Now can you see, my dear students?
Yes, sir.
Yes, sir.
Yes sir.
Okay, thank you. Let's move forward. So now I hope you understand about fatty acids. Fatty acid understood. Do I need to explain it again? Drumil?
No, sir.
Okay, let's move forward. Fatty acids occur in natural fats as ester of glycerol. Fatty acids occurs in natural fats as ester of glycerol. So all the oils you can see, or you can see the butter, they are the fatty acids, they are the ester of glycerol. Carboxylic acid, or you can see ghee. Carboxylic acid serves as a starting material for several other important organic compounds. So from this carboxylic acid, we can prepare many other carbon compounds, and they serve as a starting material for the various compounds. Using carboxylic acid as a starting material, we can prepare, number one, we can prepare anhydrides like acetic anhydrides. We can prepare esters like ethyl acetate or ethyl ethanoate, methyl ethanoate. We can prepare acid chlorides. They are like RCOCl. In the beginning of the chapter, I have explained this. We can even prepare the amides, which are RCONH2. So we can prepare the various amides, my dear students. So by using carboxylic acid as a starting material, we can prepare anhydride, we can prepare esters, we can prepare acid chlorides, and we can prepare amides easily, my dear students. Now, my dear students, we want to study about the nomenclature of the carboxylic acid. Since carboxylic acids are amongst the earliest organic compounds to be isolated from nature, a large number of them are known by their names called common names. Please remember, my dear students, that carboxylic acids are known for a longer time, and that is why they have got many names into the different regions, and they are even well known for their common names. The common name ends with the suffix ic acid. The common name ends with the suffix ic acid and have been derived from the Latin or Greek names of their natural sources. Generally, the common names are given on the basis of the substances from which they are obtained. Now, let us understand the common names from their examples. My dear students, the first example is the example of the simplest carboxylic acid, which has only one carbon, which we call it methanoic acid. It is also known as the formic acid, which is found into the sting of bees. You have studied in the 10th standard. It is found into the sting of bees, or ants or scorpions. So this formic acid was first obtained from the red ants. So in Latin, formica means ant, and that is how as it was obtained from the ants. It is in Latin it was called formica, and that is why this acid is known as the formic acid. Acetic acid, which is your CH3COOH, it is also known as the ethanoic acid. From it is obtained from the vinegar, and acetum is the word that means vinegar in Latin, and that is why on the base of the acetum it is given name acetic acid. Same way, my dear students, butyric acid CH3 CH2 CH2 COOH is obtained from the rancid butter. So for butter in Latin, there is a word butrum. So from butrum, it turns out to be butyric acid. Even the word butter is even we can easily understand that has derived from the word butrum. So butrum gives us the butyric acid, which is majorly the name from butter, or majorly due to the Latin name of butter. Same way in the IUPAC system. Now, my dear students, we should study about the IUPAC system for the carboxylic acid, dear students. In the IUPAC system, aliphatic carboxylic acids are named by replacing the ending E. So suppose you have methane, that represents one carbon. Now what you do, you remain this E. So that is what it said in the IUPAC aliphatic carboxylic acid, the name they named by replacing the E in the name of the corresponding alkane with oic acid. So now you remove this E and add oic acid. So what happens? It turns out to be methanoic acid. This is how, my dear students, you write ethanoic, propanoic, butanoic, pentanoic, hexanoic, heptanoic, octanoic, decanoic, this way. So this is how, my dear students, we understand about the nomenclature system into the IUPAC. In common name, there was only ic acid as a suffix, formic acid, acetic acid. But in IUPAC system, we have added the oic acid as a suffix. In numbering the carbon chain, the carboxylic carbon is numbered 1. Remember that whenever we number the carboxylic acid, we will give preference to the carbon, and we will write the, or we will give first number to the carbon which is included into the COOH group. So in any number of carbon, if they are bonded, we shall give this carbon as a first number. The naming for naming compounds containing more than one carboxylic group, if there are more than one carboxylic group, like this. Suppose both these CH2 have COOH. So in this case, what happens when for naming compounds containing more than one carboxylic group, the alkyl chain leaving carboxylic group is numbered, and the number of carboxylic group is indicated by adding the multiplicative prefix dicarboxylic acid, tricarboxylic acid, etc. to the name of the present alkyl chain. So we'll study them that, but we can use this prefix dicarboxylic acid like ethane dicarboxylic acid, or propane tricarboxylic acid, or propane 1,2,3 tricarboxylic acid, ethane 1,2 dicarboxylic acid, or same way, my dear students. The position of COOH are indicated by the Arabic number before multiplicative prefixes. Some Arabic number means 1, 2, 3, 4. Some of the carboxylic acids, along with their common names and IUPAC names, are listed on the next page. So let us study the various names of the carboxylic acid, and let us study them in a nice manner, my dear students. You will enjoy, I hope you will enjoy the nomenclature of the carboxylic acid. You can see here the first number carbon or carboxylic acid with one carbon. In common name, it is named as formic acid. In IUPAC name, it is named as methanoic acid. For two number carbon, you have acetic acid as a common name, and you have propanoic acid, which is ethanoic acid as an IUPAC name. For three carbon on a normal chain, the common name is propionic acid, whereas IUPAC name is propanoic acid. For four carbon uh, normal chain, that is the single chain, we have common name butyric acid, whereas IUPAC name butanoic acid. For the compound like this, you can see here this two CH3 group are bonded to this CH. This is how we have CH here, and that is what it is bonded to COOH, and this is how finally we get 2-methyl propanoic acid. So 1, 2, and 3. On second carbon we have methyl group, so it is a 2-methyl propanoic acid, or it is isobutyric acid. Uh, Isobutyric acid, because it has got 4 carbons, so they have considered it as a butyric acid. Then this COOH, the common name is oxalic acid, and here it is ethane dioic acid. You can even write ethane 1,2-dioic acid. If you have 3 carbon chain, that is what, please remember the common name, which is malonic acid, or it is also known as propane dioic acid. 3 carbon propane dioic acid. You can see here 4 carbon, so it is known as the butane dioic acid. If you have 5 carbon, it is pentane dioic acid. If you have 6 carbon, it is hexane dioic acid. But their common names are very much interesting to remember and to learn. You should learn them. With 2 COOH, we have oxalic acid, 2 carbon. If we have 2 COOH in between, we have 1 CH2, it is malonic acid. If we have COOH at both the end, and if we have CH2 for 2, it is succinic acid. If we have CH2 3 times and 2 COOH, it is known as the glutaric acid. If we have 6 carbon where we have 4 CH2, it is known as the adipic acid. So, my dear students, this is the 3 carbon. You can see here this 3 carbon. You can give them the number 1, 2, and 3. So they are making propane or 3 carbon, and all these 3 carbon have 3 COOH group bonded to them. So we can write them as propane 1, 2, 3 tricarboxylic acid. Please remember, they are propane 1, 2, 3 tricarboxylic acid. Their common name is tricarbonic acid or carboxylic acid. Please remember, the common name for propane 1, 2, 3 tricarboxylic acid is tricarboxylic acid or carbalic acid or tricarbalic acid. Same way, when we have the aromatic carboxylic acid with benzene, it goes benzoic acid. Benzoic acid is even the name which is accepted by the IUPAC system, but we can even call it as a benzene carboxylic acid. When we have benzene bonded with the CH2 COOH, in IUPAC system it is 2-phenyl ethanoic acid. So you can see that these are the 2 carbons. On second carbon we have phenyl group, so it's a 2-phenyl and ethanoic acid. It is also, in common name, it is also known as phenyl acetic acid. CH3COOH is your acetic acid. So one of the hydrogen with the acetic acid is replaced with the phenyl group, and that is why it is known as the phenyl acetic acid. When we have in ortho position 2 carboxylic acid group, it is known as the phthalic acid, which is also known as the benzene 1,2 dicarboxylic acid. It is also known as the benzene 1,2 dicarboxylic acid, my dear students. We can even study about the other compounds, like if we have 3 phenyl, if we have phenyl group bonded to the 3 carbons, so we can give them the number 1, 2 and 3. And on phenyl groups, on 3 phenyl, it is propanoic acid. This is the IUPAC name. Suppose you have the compound this where the carbon is double bonded with the another carbon, and then we have COOH, and the given carbon is bonded with 2 other CH3 group. So we should start giving numbering from here. So it's a 1, 2, 3 and 4. On third position we have methyl group. On second carbon we have double bond. So it is 3 methyl but 4 carbon total. So it's but 2 on second position in. And then it is oic acid because it's a carboxylic acid. Same way, my dear students, you can see here we have the cyclopentyl ring. So it's a on first, this is the first carbon we can consider. So we call it as a first carbon from here, and from here we'll call it second carbon. So it's a 2-methyl cyclopentane carboxylic acid. So when we write the name, we will write it carboxylic acid at the end, and it's a 2-methyl cyclopentane carboxylic acid. Same way, my dear students, we can write it here. We have benzene ring where we have the carboxylic acid. So this carbon should be given first number. When we give first number to this carbon, if you even move in this manner, it's a this is second carbon, third carbon, fourth carbon, fifth carbon, and sixth carbon. Even if you move in the anti-clockwise, the same position will be given to all the carbons. So it is 2,4,6 trinitrobenzoic acid. Please remember it is 2,4,6 trinitrobenzoic acid, which is also, so this is how, my dear students, we can give the names to the various compounds containing the carboxylic acid group. Now, my dear students, if you have any doubt into the nomenclature, you can ask me. बच्चों, अगर आपको nomenclature में कोई doubt है तो पूछ सकते हैं.
No, sir.
No doubt.
No doubt.
Understood everything?
Yes, sir.
Yes, sir.
God bless you. Let's move forward and study the structure of carboxylic acid. So let's study about the structure of the carboxylic acid. In carboxylic acid, the bond to the carboxyl carbon lie in one plane and are separated by about 120 degree. The carboxylic carbon is less electrophilic than the carbonyl carbon because of the positive resonance structure shown below. Let us study this. Now, first thing you need to mind is this carbonyl carbon is comparatively less positive as compared to the carbonyl carbon. So the carbonyl carbon present in the aldehydes and ketones, are comparatively more positive, but in a carboxylic acid group, this carbon is comparatively less positive. This carbon is comparatively less positive, and due to that, the attack of electrophile is a little more difficult. You can see here that the carboxylic carbon is less electrophilic than carbonyl carbon because of the possible resonance structures. You can see, let us understand the formation of the resonance here, that this is the carboxyl group. The electron from the double bond between carbon and oxygen move towards oxygen, so oxygen gets negative charge. The carbon gets slightly positive charge. Now, due to the positive charge, the electron from the oxygen of hydroxyl group come to carbon, and there will be double bond between the carbon and oxygen of the hydroxyl group, and thus the positive charge moves on the oxygen. So due to the presence of the hydroxyl group nearby to the carbonyl group, this carbon is comparatively, generally in aldehydes and ketones, you may generally have either carbon or hydrogen here, or carbon or hydrogen, whatever it is available, it is present over here. But in this condition, when you look at the carbonyl carbon, both here there is a presence of oxygen into the hydroxyl group, and this electron pair present on oxygen make this carbon less positive, and this is how uh, the carbon of carboxyl group is less available, or is the attack of the electrophile is, sorry, the attack of the nucleophile is less possible here in case of the carboxylic group. Now, my dear students, we want to study about the methods of preparation of the carboxylic acid. Though we have some of them we might have discussed, we'll try to minimize their discussion here as much as possible. From primary alcohols and aldehydes. So we are well aware that from by the oxidation process, from primary alcohols and aldehydes, we can easily convert or easily prepare carboxylic acid. Primary alcohols are readily oxidized to carboxylic acid with the common oxidizing reagent. They are strong oxidizing reagent like potassium permanganate KMnO4, potassium dichromate K2Cr2O7, chromic trioxide CrO3, and if chromic trioxide in acidic medium, it is known as the Jones reagents. So this Jones reagent is a strong oxidizing agent, whereas chromic oxide alone is a weak or mild oxidizing agent. So you can easily understand, my dear students, that any alcohol which is RCH2OH in the alkaline KMnO4 or acidified KMnO4, it converts alcohol into carboxylic acid. So RCH2OH is converted to RCOOH. Even a long chain carboxylic acid, which has 10 carbon, one decanol, that can also be converted to the decanoic acid by the Jones reagent, chromic oxide in the acidic medium. Please remember the Jones reagent, which is the strong reagent which contains the chromium oxide CrO3 in acidic medium. Then let us look at some other examples. If we have butane 1-ol with 4 carbon, in the presence of the Jones reagent, it is converted into butanoic acid. We must know that formaldehyde, or from aldehyde also, we can prepare carboxylic acid. So by using the mild oxidizing agent called Tollens reagent, which is nothing but your ammoniacal silver nitrate, if we allow the butanol with 4 carbon aldehyde, allow it to react with the Tollens reagent, we will get butanoic acid formed from this. First we get the iron, and then in the presence of water or acid, it is converted to butanoic acid. The second method for the preparation of the benzoic acid is from the alkyl benzenes. So aromatic or carboxylic acids can be prepared by the vigorous oxidation of alkyl benzene. What do you mean by alkyl benzene? So you have benzene structure. On this benzene structure, my dear students, we are bonded with the methyl group, like we have toluene. We can have ethyl group that is bonded to the benzene. It is known as the ethyl benzene. So by using such compounds, even by doing their vigorous oxidation, we can prepare carboxylic acids. So by vigorous oxidation of alkyl benzene with chromic acid or acetic chromic acid or acids or alkaline potassium permanganate, the entire side chain, if here you have whatever the long number of carbon, whatever the number of carbon present, the entire side chain is oxidized to carboxylic group irrespective of the length of the side chain. Primary and secondary alkyl groups are oxidized in this manner, while tertiary group is not affected. Please remember that primary and secondary alkyl group can be oxidized. Suitably substituted alkenes are also oxidized to carboxylic acid with this oxidizing reagent. So even if we have something bonded to the benzene, substituted alkenes can also be oxidized to the carboxylic acid. Let us understand this with a few examples. Let's move forward. If we have toluene and if we do the oxidation of toluene with the alkaline or acidified KMnO4, we first get potassium benzoate and then finally we get benzoic acid. If we have propyl benzene, that means if we have 3 carbon bonded to benzene, it is also converted to the benzoic acid, where we have the 1 carbon present on the phenyl group. So even this ring is of 5 carbon, CH2, 4 CH3, or even the very long chain is available. Or my dear students, if we have the secondary group bonded to the in the benzene, like if you have CH, then here you have CH2, CH3, and here we have CH3. Even if this such compound is oxidized, it will oxidize to benzoic acid only, irrespective of the length of the side chain. When you oxidize such compound which have directly which have carbon, which is secondary carbon directly bonded, this is what it is going to be tertiary carbon. It is not, but tertiary carbon will not be affected, but secondary carbon can be easily turned out to the benzoic acid. So what compound I have shown, that will also be, even it has got branches. See, if this is the case, just a minute, we'll see it into somewhere here. Let me show you with white. See, if you have benzene bonded to the chain, which is a long chain, you can see here. Suppose this kind of chain is present, and this chain has got branch. So with you, like, we need not to think about anything else. If we oxidize it, on oxidation, it will, if we oxidize it with the KMnO4, if we oxidize it with KMnO4, we can easily get the benzoic acid from it. So irrespective of whatever the length of the alkyl group, whether the alkyl group has got the branches, irrespective of anything, it will only give benzoic acid as a product. So my dear students, irrespective of the length of the alkyl chain, we will definitely get benzoic acid as the final product. Even if, my dear students, if we have benzoic, if we have this, you can see in this compound, the alkyl benzene, it's substituted with the COCH3 group. On oxidizing it, both COCH3 and CH3 will be converted into the COOH group, and we will get the benzene 1,4-dicarboxylic acid, which is also known as the terephthalic acid. So please remember, my dear students, that even if the substituted benzene are available, the alkyl chain will be converted into COOH group. Now I would like to share few more names with you, my dear students, that if you look at this, and if you have the compound with benzene, where you have the carboxylic acid bonded to the ortho position this way. Suppose COOH is bonded here, and COOH is bonded on the next position. We shall call it phthalic acid. But if both the benzene groups or both the carboxyl group present on the phenyl ring are at 1 and 4 position, then they are known as the terephthalic acid. Please remember. So two carboxylic acid group on ortho position will give us the phthalic acid. Two carboxylic group on para position will give us the terephthalic acid. This is how, my dear students, we understand about the nomenclature of these compounds. These are very important compounds, so I have discussed their names with you. Now let's move forward and understand what about the cyclic alkanes, my dear students. If we have cyclic alkenes, that is, if there is a double bond between the cyclic ring, and if we oxidize it with the KMnO4 into H2SO4 acidified KMnO4, it will give us the hexane 1,6-dioic acid, which is also known as the adipic acid. This is also the method of preparation of adipic acid. Please remember this conversion, my dear students. It is IMP and can be asked into the various exams. Now, my dear students, we are going to study the preparation of these compounds uh, by using the nitriles. So, nitriles means cyanide compounds. You have C triple bond N. So, from these nitriles or amides, we can even prepare the carboxylic acid. You can see here that from RCN, first we hydrolyze it in the presence of acid and alkali. We get RCONH2, and then this RCONH2 again hydrolyzed to the carboxylic acid. Same way, if we have uh, amide CONH2, that also on hydrolysis gives us the ethanoic acid. So let's understand this, my dear students, that nitriles are hydrolyzed to amides and then to acids in the presence of H plus or OH minus as a catalyst. Same way, my dear students, mild reaction conditions are used to stop the reaction at amide stage. So, if the reaction conditions are mild, these nitriles are stopped at up to amides. So, from nitriles we can prepare amides. But if the conditions are not mild, if they are stronger, then we shall get the carboxylic acid. Let us understand with the example, my dear students. If we have ethanamide, then on hydrolysis it gives the ethanoic acid and ammonia. If we have benzamide, then on hydrolysis it gives us the benzoic acid and ammonia. So my dear students, now if you have any doubt, you can ask me your doubts. Dear students, do you have anything which you could not understand? You can ask me so that I can re-explain it to you.
No doubt, sir.
Everybody? Everybody in the class?
No doubt,
Yes,
sir.
sir.
No, sir.
Okay,
No doubts.
let us revise whatever we have studied and then you can move to the next class. So let me go for a revision. In today's class, my dear students, we have studied the about the carboxylic acid. You have seen that carboxylic acid are the compounds that are obtained from the nature in a various ways. So carboxylic acids are obtained from butter, they are butyric acid, they are obtained from the ant, which are known as the formic acid or methanoic acid. They are also obtained from the vinegar, which is known as the acetic acid. And they have been known for a longer time. The long chain carboxylic acid containing the number of carbon C12 to C18 are known as the fatty acids, which are even present in our body as a fats, as well as in various oils and ghees we can get such fatty acids. From carboxylic acid we can prepare anhydrides, esters, acid chlorides and amides. We give them names and we have studied the various ways to write their names, as we have studied their common names as well as the IUPAC names. And then, my dear students, we have studied the method of preparation, we have studied the structure of the carboxylic acid. We have seen that the carboxyl carbon is comparatively less positive as compared to the carbonyl carbon present into the aldehydes and ketone, and that is why the attack of nucleophile uh, is less possible. Same way, my dear students, we can prepare the carboxylic acid from the primary alcohols by the strong oxidizing agent and from aldehydes by the mild oxidizing agent. Same way from alkyl benzenes or from the alkanes, we can directly convert them to the benzoic acid by the strong oxidizing agent like alkaline or acidified KMnO4, acidified K2Cr2O7, or Jones reagent, which is known as the chromic acid into the acidic medium. Same thing if we have the cyclic alkenes. This cyclic alkene, the cyclic bonds are being broken and both the sides are converted, both the side or both the carbons are converted to carboxylic acid group, and this is how from cyclohexane we can get hexane 1,6-dioic acid, which is known as the adipic acid. Even from nitriles, my dear students, we can prepare the carboxylic acid, or nitriles on hydrolysis first are converted to amides, and in vigorous condition these amides are again converted to carboxylic acid. Or even if we have only amides like ethanamide or benzamide present with us, by hydrolysis these amides are converted to the carboxylic acid. I hope, my dear students, you have enjoyed these studies, and I wish you happy learning. Let us end the class today. If you have anything to ask, you can ask, or you can leave for the next class.